Okay, good afternoon, good morning. Hi everyone. How's your day? How's your week? So how's your midterm? Okay, so I hope you are fine. Your day are good. Okay, so for this video, okay, so I recorded this video to have a discussion with our exercise number 5. So we're not able to discuss this previous week. Yeah, previous week because of inconvenience, technicalities. So I am having this recorded video to catch up with our lab exercises. Okay, so for today's discussion, for today's video, so I'm going to discuss to you about distillation of binary system. Okay, so when we say distillation, so from the previous chemistry that you have experience or you have encountered, so of course it's not new to you, what are distillation or what is distillation. Okay, so when we say distillation, it deals with separation, purification, or extraction, okay, of components in a mixture, or you have something to purify, okay, to remove the impurities of that substance. Okay, so that is distillation. Now we will deal also with distillation, okay, with relation to the binary systems. Okay, you have two component system of your mixture, liquid mixture, and then we will make a phase diagram for it. Okay, so we will identify, we will determine, okay, so on what temperature, on what condition, okay, so the liquid or the vapor phase occurs, or equilibrium of the liquid and the vapor occurs or exist. Okay, so I will share to you my discussion slide. Okay, short discussion slide lang. So this is our exercise number 5. Okay. So our learning outcomes for this experiment, for this exercise, first you have to separate liquids from the mixture by distillation. And then second, you determine the boiling point and composition of each component of mixture. And the last one, you will construct the boiling point composition diagram for a completely miscible binary liquids. But before that, we will discuss, or we will have a short discussion on what are the binary complex or the liquid-liquid nga equilibrium mixtures or liquids conditions niya. So let's have a short discussion of it. All right. So when we say liquid vapor equilibrium, so diba ang equilibrium is the it means they two phases that exist equally. Okay, so naa sila'y balance nga amount, okay, balance amount of the um, phase, okay, that exist in that particular mixture. So of course, this system or this equilibrium condition composed of two system, okay, composed of two systems, and we have cases. Okay, we have different cases with in terms of liquid vapor equilibrium. So first case, you have the completely miscible, and then second case, you have the partially miscible, and the third one is the completely immiscible system, binary liquid system. So when we say completely miscible, so the two component liquids are, or they produce homogeneous mixture. So they have only one phase. Okay, so they dissolve to each other. Okay, and then they produce. Okay, so they produce one phase only. And then when we say partially miscible, so some of the ions that is present in that liquid are do not dissolve, and some of those dissolved. Okay, on that particular components. And last, you have this completely immiscible. When we say completely immiscible, from the word itself, immiscible, okay, so baliktad. It's the opposite of the miscible word. So, dili siya musagol. Okay? It will not dissolve to each other. So it will not combine to each other. So in other words, they will produce two layers. Okay? Two layers of liquids. Okay? In a mixture. Okay, so as you can see here, you have this component A, okay, in which it has its respective molecules. Okay, and then you have also this component B, and of course, it has its respective gihapon na mga molecules. Okay, from the liquid phase, okay, you have this one, you have this liquid phase ng mga atoms or molecules, and then some of the atoms or molecules that are present in the liquid phase, um, it needs energy, or due to its volatility of again, okay, so due to its volatility, so it will convert into its gaseous phase, okay, to its vapor phase. Same with this component B. And then these components, okay, component liquids, they have their own partial pressures. Okay, they have their own partial pressures. It depends on its volatility characteristics or their polarities. Okay, so it matters on it. So now, as we proceed to this liquid vapor equilibrium, so it composed of two systems. So we will compute the variance of this equilibrium, liquid vapor equilibrium. Okay. So the equation that we're going to use to calculate or to find the variance of a system, so you can have it F is equals to 2. So this 2 represents the variables. Okay, so what are the factors that we are considering in that particular system? So we have two variables, which are the pressure and the temperature. Okay, and then plus the C. This C represents the number of components, okay, in that system. So since you have this liquid vapor equilibrium, so you have two systems, so your component number of components is 2 minus the P. So P is the phase produced in that particular system. Okay, so since that two represents the temperature and the pressure, and then we will consider a system that has only one variable, and then the other variable is constant. Okay, so either we will fix our temperature, or we will constant, or we will make a constant of our pressure. Okay, so since one variable is constant, so it will become 1 plus C minus P. So C is the number of components. Okay, so it is equal to 2. So F is equals to 1 plus 2 minus P, which is equals to 3 minus P. Okay, so the variance that we determine to this liquid vapor equilibrium is 3 minus P. Okay, so you deal with three phases, okay, on this one. Okay, so we have different cases also. Okay, different types of completely miscible binary liquid system. Okay, we have this first, the ideal solution. So we will deal on this ideal solution. Okay, ideal solution system, which follows the Raoult's law. The second one, second case of this completely miscible liquid system, is you have the non-ideal solution. Okay, but then we will focus on the ideal solution. So ideal solution, um, since we have this three variables that we're going to focus on this binary liquid system. So you have first the temperature, the pressure, and of course, for this ideal solution, you will include the composition of the liquid. Okay, it is very important to know the composition of that particular component. Okay, so in order for you to see how how much or the amount, or you will able to determine the amount of that particular components, okay, that is converted on that particular phase at that particular temperature or pressure. Okay, so with our experiment, okay, so with our experiment that we that is doable, supposed to be in our laboratory, so we will deal on the temperature composition diagram. Okay, so with this binary liquid system. So we have two components in which they have different boiling points. Okay, they have different boiling points. One component, liquid, has higher boiling point, and the other one has lower boiling point. Okay, and then boiling points also um, what's this? Connects to the volatility characteristic of a liquid. So the more volatile your liquids, okay, so the lower the boiling point the liquid has. And then so the higher the boiling point naman, okay, for the higher boiling point, so less na po ang iyang volatility. So it will not it takes higher energy to convert the liquid molecules to vapor molecules, okay, for the higher boiling points. Okay, so this is an example of a binary phase diagram. Okay, so where you can plot this um, between the composition of the components, two component system, and you have this boiling point niya, or the temperature. Okay, the temperature of the system. Okay, uh, upon the distillation. Okay, so as you can see here, as you can see in the diagram, so you have here this component A, and you have here this component B. Okay, so component A, okay, so component A um, has a higher boiling point. Okay, so it means less ang iyahang volatility. So less volatile siya compared to component B, which is lower ang iyahang boiling point and more volatile than component A. Okay, so this ideal solution, or this kanang phase diagram, can be applied. Okay, so it is an application of the distillation process. Okay, so where you will determine the distillate and the vapor, and then you will extract one component from that liquid system. Okay, and then you will determine the composition of that distillate ba, or this components of that liquid in that particular phase. Like, you will determine component A nga composition in the vapor phase, or in the liquid phase niya. Okay? So that is. So as you can see here, you have this temperature 1. Okay? This temperature 1 is labeled here. So as you can see this point, okay, so nakay composition 1 and you have this composition 2. And you plot this, okay, you connect this with the phase diagram. Okay, so supposed to be, kita maghimo ani siya sa diagram. No, yeah, kita maghimo gid sa diagram from our what's this? From our results. Okay? But then this is an example lang. Okay? For the already made na siya nga phase diagram. So you have here this temperature 1. Okay? So as you can see, the line, straight line nga naa niya. Okay? So this point here, okay, so this point here, naa siya'y pangalan. Okay, by the way, so this thigh line here, this line, okay, for this one, this is the vapor composition. Okay, this represents the vapor composition of the system, and this blue line, this blue tie line here, represents the liquid composition, okay, of the system. And then this part here, in between with the vapor and the liquid composition, happens your equilibrium. Okay, so you have here the equilibrium. It means you have two phases that exist here. Okay, so naay duha ka phases that exist here, which are the vapor and the liquid nga phase. Okay, so it existed here. So you have temperatures that both phases occurs. Okay, and you have also temperature that only one phase occurs. Okay, one phase lang ang exist. Aha. Okay, so let's go back to this temperature 1 nga label. Okay, for example, you have this first composition C1, and then you will find the liquid composition niya. Ang first liquid composition, I mean liquid phase nga um liquid phase niya nga na exist siya, okay, or ni occur siya. So for example, we can have this here. Okay, so in this point here, okay, at composition 1, so supposed to be you have this composition. So yan na lang nato siya taga ano example nga composition. So this point here, this is the point where the first liquid phase occur. Okay, the first liquid phase occur. So, ang makuha nimo or makakolect na kaana og distillate in that particular phase with ani siya composition at C1, composition 1. So, it can be for this one, so ato na i-estimate. So, pwede ni siya 25% of A, and then you have this 75% of A and then 25% of B. Okay? That is the composition for this point here. Okay, nga first nimo ma-observe ang iyahang liquid nga phase. Okay, liquid phase. And then as you draw a line here, as you draw a straight line here, so same sila og temperature. Okay, you can have the same temperature, but then it has different composition. Okay, different composition ang iyahang system, okay, of the liquid system. So this point here, okay, so represents the first vapor phase exist, okay, in that particular system. Okay, at this composition. So same lang sila og temperature. Okay, but then it's because lahi-lahi ang iyang composition. They have different composition of the two liquid system or the two components. So they have different points. Okay, so they have different points for the first liquid phase and for the first vapor phase. So what are what they called them? Okay, so you have here. Okay, so you have here. So for this point here, when you observe the first drop or the first liquid phase of this particular C1 composition, so it is called the bubble point. Okay, so bubble point, makita nimo or you can see, makita mo na siya ang first nga drop, okay? First liquid drop of the system. And then this point here, so katong yung vertical line, yung horizontal line, okay? In which same lang siya ang ng temperature, but then they have different composition. You have the C2 here. So this is the first point that you can observe the vapor phase of this particular composition. Okay? So this one. So we have here this dew point. Okay? So mo ni siya gitawag nga dew point. Okay? It is called the dew point. So from the word itself, dew nga kanang murag yamog yata. Yeah, so this is the dew point. Okay? So this is how you interpret the phase diagram, the binary phase diagram. So in an ideal solution, for example, okay, so as you can see here, kani siya nga mga lines, okay, si composition 4 and si composition 5. Okay, so sa composition 1, okay, with the composition 1, um, we focused only on the bubble point niya, okay, the bubble point, and also with the C2, yeah, the bubble point and the dew point of the C2. And here, with the C3, kuan gihapon, the bubble point and the dew point gihapon ang ipakita, gi-display. But then if we are going to increase the temperature of um, this C2 nga liquid system. So as you can see here, this point, so taas na siya og temperature from the bubble point. Okay? So this one here, okay, so this one here, you can predict, okay, so you can see, okay, diba, in between these two tie lines, you can have the equilibrium. So therefore, nag-exist ang duha ka phase, the liquid phase and the vapor phase. So in this temperature here, in this point here, so you have these two phases, the liquid and the vapor phases. Okay? So with this one, so as you can draw a horizontal line, okay, to its bubble point and its dew point, so that would be the composition 4 and the composition 5. Okay, so that we will see the composition 4 in this one and the composition 5. Okay. So same lang sila og temperature, okay? They have the same temperature, but then they have the same composition, okay? At then different po ang ilahang points. Okay, so we have 3 points here. You have this equilibrium point, and this you have this bubble point and the dew point. So how to get their composition? Liquid nga composition niya after the distillation, and you have this vapor composition after the distillation, okay, after the process. So we will assume that C4 contains yung composition, you have this 40% A and the 60% B, and then C5 you have this 70% A and 30% B. Okay, C5 and then C4. So how to get their mole fraction? Okay, mole fraction. So we will consider the distance. Okay, the distance of these 2 points. 3 points, I mean. So these 3 points. So this is the equilibrium point, this is the bubble point, and this is the dew point. Okay. So how to get their mole fraction, okay, sa liquid o sa vapor niya nga phase. So first you have to determine their distance. So in the mole fraction of the liquid, sorry, liquid is siya class, this is Q. Okay, so the mole fraction of the liquid is equals to the distance 2 over distance 1 plus distance 2. And then you have this mole fraction of vapor, which is equals to D1 over D1 plus D2. Okay, so um, how to get this? So, pinaagi sa iyahang composition, okay, you will determine their distance. Okay, so for C4, you have this 40% A and 60% B, and then you have C5, you have 70% A and 30% B. So let's deal with A, composition A lang sa. Okay? Let's have this composition A na calculation. Okay, so distance 2 of the composition A. Okay, so you have this distance 1 and you have this distance 2. Okay, so this one, so si C2, gi-assume po J 60% A and 40% B. So this is the distance 1 and this is the distance 2. Okay, so since distance 2, kani siya, so from C5 minus sa C2. Okay, so C2, gi-assume na siya as 60% A and then 40% nga B. So 70 minus 60, which is equals to 10. Okay, so this is the distance 2, and then you divide this with the summation of the distance 1 and 2. So 10 plus 20, which is equals to 30. So 10 divided by 30 is equals to 0.33. So this is the mole fraction of the liquid. Okay? The liquid nga phase. And then let's proceed to the mole fraction of the vapor, okay, in which ang iyang equation is D1, distance 1, divided by distance 2 plus distance 1 and 2, okay? Summation of distance 1 and 2. So replace it with the numerical value. So distance 1 is equals to 20. It's because 60 ang composition A with C2. Okay, minus from the C4, which is 40%. So it is equal to 20 divided by 30. Okay, so 10 plus 20, which is equals to 0.67. Okay, so these are the mole fraction, okay, uh, mole fraction of the liquid phase and the vapor nga phase. Okay, so this is how you represent or you interpret the phase diagram, the binary phase diagram, specifically the temperature composition phase nga diagram. Okay, so I will post additional nga discussion video, okay, from the YouTube. Okay, so para you have another idea on how to interpret and do the phase diagram, okay, in our Moodle classroom. So I will post on that classroom, in the classroom. Okay, so we have here the data. I will provide you the data, okay, of the distillation process. And also, I will also post the link of the procedure that we are going to use for this exercise or for this experiment. Okay, so this is the data. Actually, class, this data is from the previous nga mga datas that I gathered from my students. Okay, so sa atong previous nga physical chem. Okay, graduate na. Okay, those persons graduated already. So I gathered their results. So that is why nga I provide these results na lang siya. Okay, kay the video that I'm going to post kay nga it is already in YouTube. They are not specified ang iyahang um, data. Okay? It is not shown or it is not displayed on the video the data they gathered. Okay? Only the procedure. Okay? They specify only the procedure. So, I'm going to provide to you the data. So, this is from the previous nga experiments, okay, from your mga seniors, okay, sa una. Okay, so this is it. So after the distillation, okay, after thorough distillation, so you have several boiling points, okay. Okay, so you have 118 because the mixture that we are going to use is the acetic acid and water nga liquid system. Okay, acetic acid and water. So water has approximately 100 degrees nga boiling point, but see acetic acid has higher boiling point than water, which is I think 120, 118, 19 degrees Celsius ang iyahang boiling point. So, mas higher si acetic acid than the water. Okay, so or in that part, we are going to determine the composition of the two components of the acetic acid and the water at a particular temperature. Okay, at a particular boiling point. Okay, so the first temperature that we are um, recorded that we had recorded is from 118 degrees Celsius. Then next you have 114, 112, 108, and 104. Okay, so it depends on um, the distillate that we collected. Okay, so we will read after we reach I think mga 5 manyata to 5 ml of distillate. Okay, so we recorded the temperature. Okay, so that is the boiling point that we recorded here. So until 104, okay, ang ato ang boiling point nga gi-run or I mean gi-record recorded on that experiment. Okay, so after we had this distillation set up, so we have collected the distillate and then yung residue, okay, which is from the mixture itself. Okay, so this one, you can see mga codes here. So M1 represents for the residue or katong mixture, sample mixture. And then D is for the distillate, okay? Distillate that are collected during the distillation process. Okay, M1 and M2, so we have two trials, okay, for M1 and M2. And D1 also and for D2. So after the distillation, in order to determine the concentration or the composition of one of its component. Okay, so the easiest way to find it, okay, or to determine it is to get the concentration or ang percent niya ni acetic acid through titration. Okay, after the distillation, the collected samples or the collected nga residue and distillate, they proceed to titration. Okay, that is why we have data here, ml of NaOH, and then through this volume of NaOH, we can calculate or we can determine the mole percent of acetic acid. Okay, so from this one, you can get the concentration. I believe that you know how to get the concentration out from this data. Okay, so volume of the NaOH. Okay, titration nga data. So we have tackled this many times on how to get the concentration of the acid using the titration data. Okay, so mao pud ni siya ang gigamit, okay? Ito pa rin ang yung equation na yon, okay? So the same equation ang ginagamit for this experiment. Then so you will get the concentration of the acetic acid, and then you can compute the mole percent of the acetic acid on it. So since isa lang man ang ang mole, ang proton of the acetic acid, so um, s- it's easy to determine the mole percent of the acetic acid. So this one here is the mole percent of the acetic acid. So I didn't provide you the average, so you get the average of it for the distillate and the residue or the mixture. And then for the next table, this is the table 1. And then for the next table, you have this mole percent of water. So the first table, you have the mole percent of acetic acid. That is the component 1. And then next, you have this component 2, which is the water. Okay, so how to get the mole percent of the water? Okay, di ba? Sa usa ka mixture, the mole percent is um, considered as 1.0. Mole fraction of it is 1.0 or 100% nga mole percent, okay, of that mixture. So now, how to get the mole percent of water? So, kuan lang siya. 100 minus the mole percent of the acetic acid. That would be your mole percent of water. Okay, and then you get the average and then fill this table on the template and the laboratory format that I have given, that I will be given to you. Okay, sa atong Moodle classroom. That I will post it in the Moodle classroom. Okay, so this is the second table that you are going to fill out. And then after getting this tables, this data, so this one you are going to make a phase diagram nga, binary phase diagram, temperature and composition phase diagram out of this data. So you are going to plot this one from the boiling, between the boiling point and the average composition of the water and the acetic acid. So you can find or you can create those tie lines, duha ka tie lines nga nakita nato from the previous slides. Okay? So that is our exercise number 5, the distillation of binary liquids. Okay, so we're from for this exercise, for this experiment, we use um the simple distillation setup. Okay, simple distillation setup ato ang gigamit. I don't know, ang next na to nga exercise, I didn't think if magamit ta og steam distillation. Okay, so as for now, we should use, or supposedly we will use the simple distillation setup in the lab for this exercise. Okay? So that's it for our exercise number 5. Thank you for listening, and I hope you understand our discussion for this video. Okay? So have a nice day and keep working on your laboratory reports. Goodbye.